top. Okay, we'll look at the homework problems that are in section 7.2. We'll start with problem number 1, where Steve went to the store and bought a chair for $18.15, a rake for $14.92, a spade for $12.16, a mower for $132.07, and 2 6-packs of water for $2.64 each. What was the bill? Okay, so this is just a simple addition problem, and we'll set that up like this. You have the chair, which is $18.15. Then the rake is $14.92. A spade for $12.16. And then the mower costs $132.07. And you're told you had 2 6-packs of water for $2.64. So we have to write $2.64 twice. Okay, now we can add this column by column, or if you wish, you may use a calculator if you wish, and then you'll get the final answer of $182.58. So that would be the total cost of the bill, $182.58. In number 2, a U.S. $1 bill was valued at 0.9214 Swiss francs or Swiss currency on a particular day. What was the value of $23.84 in American dollars in Swiss francs on that day? Simply take $23.84, multiply that by 0.9214, and I've set this up like this. Now, you may use a calculator. 0.9214 times 23.84. Now you're going to get 21.966176 as the answer. Now, the problem asks you to round to the nearest hundredth as needed. Okay? This number is in the hundredths place. That's a 6. To the right of it is another 6. That 6 is bigger than 5, so this 6 that I've underlined needs to be increased to a 7. So it'll end up being 21.97. And then all these other numbers will drop off completely. Okay. Problem number 3. A kilowatt hour means 1,000 watts of electricity are being used continuously for 1 hour. The electric utility company in Laura's town charges $0.03452 for each kilowatt hour used. Laura heats her home with 3 electric heaters that use 1,200 watts per hour. How much does it cost to heat her house in 1 day? Okay, now let's look at how this problem is going to be done. The 1,200 watts. Now, we want this in a kilowatt hour because the cost is going to be this amount for each kilowatt hour used. And we have 1,200 watts. We know that 1,000 watts is a kilowatt hour, so let's take 1,200 and divide that by 1,000. And that would give us 1.2. Okay. Now she has 3 electric heaters. So 1.2 times 3. That would give us 3.6. So here she's using 3.6 kilowatt hours. And then that's going to be multiplied by 0.03452. So if you do 3.6 times 0.03452, okay, all right, that's 1.2. Then there's 3 electric heaters. That's going to be 3.6 kilowatts per hour. Okay, and then that's going to give us, let's see, 0.124272. And I need to multiply that by 24 hours. Okay, because keep in mind, for a day, there's 24 hours in a day. So if we multiply that by 24, you're going to get 2.982528. Now we're going to round to the nearest cent. Okay, or to 2 decimal places. That means that the 8 is in the second digit behind the decimal point. Next to it is a 2. It's less than 5, so it'll round up to $2.98. Okay, so it's going to cost her approximately $2.98. Okay. All right, number 4 is to solve this problem. The water in the tank weighs 731.25 pounds. 1 cubic foot of water weighs 62.5 pounds. How many cubic feet of water does the tank hold? This one I'm going to do by long division. In this case, we got 731.25 pounds of water, and each cubic foot of water has a weight of 62.5 pounds. So we're going to divide that by 62.5 to find out how many cubic feet of water will the tank hold. Okay, now think of this. When we divide decimals, we always make the divisor a whole number by moving the decimal point how many places we need to move to make it a whole number. In this case, we need to move the decimal point 1 place to the right. If we move this decimal point 1 place to the right, in the dividend, we must also move the decimal point 1 place to the right, and then bring this decimal up in the quotient, and then do our division. We're going to divide 625 into 731. That's going to go 1 time. So 1 times 625 is 625. Then subtract 625 from 731. You're going to get 106. Then you're going to bring down the next digit, which is a 2. Then divide 625 into 1062. Again, that's going to go 1 time. 1 times 625 is 625. Subtract that from the 1062. You'll get 437. Then bring down the 5. And then divide 625 into 4375. Okay, and that's going to go 7 times. 7 times 5, that's 35. 7 times 2 is 14. Times 3 is 7. Carry the 1. 42 plus 3. 1 is 43. You have a 0 remainder. So here the tank will hold 11.7 cubic feet of water. Okay. So that's how you would do long division here in this particular situation. Again, you may use a calculator if you want to, but you have to know that this number goes in first and then divided by 62.5. Okay, problem number 5. A bank statement showing a checking account with a balance of $55.73. The balance recorded in the checkbook shows only $23.24. After checking the canceled checks against the record of those checks, the customer finds that the bank has not yet recorded 6 checks in the amounts of $9.05, $2.36, $3.94, $2.64, $5.34, and $4.66. Is the bank record correct? Okay, now the first thing you have to do here is add up those those checks that were not recorded. So here you got $9.05, $2.36, $3.94, $2.64, $5.34, and $4.66. Okay, in this case here, those checks that were not yet recorded add up to $27.99. Now, if we add the $27.99 to the $23.24, we come up with $51.23, and it's supposed to add up to $55.73. And in this case, we have to say no, that this bank record is not correct, and we want to find out how much is the bank over. Well, subtract the $55.73 that the bank has written down, and then we came up with an amount of $51.23. Here the bank is over by this amount, $4.50. Okay, so the bank is over $4.50. Problem number 6. Going to take a number that's in scientific notation and convert it to decimal notation. We got 8.3 times 10 to the 7th. Okay, our exponent is 7. That's going to tell us how many decimal places we need to move to the left or to the right. Okay, and it's a positive 7, so that means we need to move this decimal point in 8.3 7 places to the right. So here we move the decimal point 1, 2, 3, 4, 5, 6, 7. And we need to add zeros here. So in this case here, we're going to have 83 million as our answer. All right, problem number 7. Write the numeral in the sentence in scientific notation. The distance between two planets is 2,200,000,000 meters. 2,200,000,000 meters. Now, the way we write this in scientific notation, we're going to have to place the decimal point behind the very first non-zero digit. So here, the first non-zero digit, here's the 2, so we place that decimal point behind that first 2. So we're going to have 2.2 multiplied by 10, and then to come up with the exponent for 10, we count how many digits are after the decimal point that I placed behind it. If I put it behind the first 2, that means that there are 9 numbers behind it. That represents the exponent for 9. For 10. So it'll be 2.2 times 10 to the 9th power, written in scientific notation. Okay. Problem number 8. Write the numerals in the sentence in standard form. Okay. John's annual salary is 8.9 times 10 to the $4. Okay. The exponent for the 10 is the 4, so we need to move this decimal point in 8.9, 1, 2, 3, 4. And then add 3 zeros behind it, so it will be 89,000. So John's annual salary in standard form will be $89,000. Problem number 9. We're going to multiply and write the result in scientific notation. We got 3 times 10 to the 6th times 6 times 10 to the 5th power. Okay, in this case here, we're going to multiply the numbers that are in front of the power of 10. So 3 times 6, that would give us 18, times 10 to the 6 times 10 to the 5th. We're multiplying powers of the same base, so we add the exponents here. So it'll be 10 to the 6 plus 5, which will be 11. Now, this is not written in scientific notation because the 18 is bigger than 10. Scientific notation states that the first part must be at least 1 but less than 10, multiplied by a power of 10. So we need to write 18 as in scientific notation. If we put the decimal point behind the 1, it'll be 1.8. And there's one number behind that decimal point, so it'll be 10 to the first power. Then that's multiplied by 10 to the 11th. And then we add the exponents for 10. So it'll be 1.8 times 10 to the 1 plus 11, which will be 12. So in this case here, it will be 1.8 times 10 to the 12th power. That's the answer for 3 times 10 to the 6 times 6 times 10 to the 5th. Problem number 10 is rounding this decimal 688.149 to the nearest hundredth, to the nearest tenth, the nearest unit, nearest 10, and the nearest hundredth. Okay, to the nearest hundredth, the number in the hundreds place is a 4. To the right of it is a 9. 9 is bigger than 5, so we increase the 4 to a 5. So this will be 688.15. That's the number rounded to the nearest hundred. Same number, but to the nearest tenth. The number in the tenth place is a 1. Next to it is a 4. 4 is less than 5, so the 1 remains the same. So it'll only be 688.1. And we drop off all the numbers that are behind it. To the nearest unit, or to the nearest whole number, we look at the ones place, or the units place. That's the 8. That's the second 8 right here. To the right of it is a 1. That 1 is less than 5, so this 8 remains the same. So it'll only be 688. And all the numbers that are after the decimal point are dropped off. Okay, 688.149 to the nearest 10. This 8 right here that's immediately after the 6, that's the number in the tens place. To the right of it is another 8. 8 is bigger than 5, so this first 8 will increase to a 9. So it'll be 6, 9, but this 8 will change to a 0. So it'll be 690. And then finally 688.149 to the nearest hundred. The 6 is in the hundreds place. Next to it is an 8. 8 is bigger than 5, so the 6 will increase to a 7. And those 8s will change to zeros. The 149 is dropped off completely. So 688.149 to the nearest hundred will be 700. Problem number 11. A car went 262 miles and 13 gallons of gas. How many miles to the gallon does the car get, rounded to the nearest mile? Okay. Now, let's do a little estimation here of 262. I'm going to estimate 262 to 260 and leave 13 as is, because I know 26 or 260 is a multiple of 13. So that's why I'm using 260. Okay. So in this case here, if I do 260 divided by 13, well, 26 divided by 13 is 2. And just put the 0 behind it. So 260 divided by 13 must be 20. So the car gets approximately 20 miles to the gallon. And finally, number 12, John wants to buy some camera equipment. To estimate the total cost, he rounds each price to the nearest dollar and adds the rounded prices. What is his estimate for the items listed? Okay, let's round each one of these to the nearest dollar. The camera is $56.47. So to the nearest dollar, that would be just simply $56. The film is $17.86. Well, $17.86 is closer to $18, so we'll round to 18. The case is $9.08. We'll just round that off to 9. So 56 plus 18, that's 74. 74 plus 9 will simply give me 83. So the estimate for these items listed would simply be $83. And that should assist you with some of the homework problems in section 7.2.